Today we're going to look at how to handle pinouts in IBDs and the system model. So I've started off by creating some notional signals here with some specialization so we can show specific types of signals. And we've set up a -3 and +3 volt DC here to make sure that if we care about that as far as routing, we have separate types of signals and we can have separate types of flow properties to ensure we don't accidentally wire things up incorrectly. We have here some interface blocks I've created. Notice that the flow properties follow our convention of going out when they're unidirectional, so we can conjugate them for ins. And I also have a reserved interface block that we'll use in a little bit. One thing I've done here is I've set up the signals in a table to show that you can also kind of follow them to see what sort of interfaces can legally flow them. And so what we will look at here is the custom metachains that I set up. So interface blocks, in this particular case, the metachain is pretty straightforward. We go from the signal to the typed element of type, which in our case is flow properties, and then who owns them. And so when you do that, it basically lets you see who owns it. And then in the case of the all interface blocks, we do a slight additional step there, and we go ahead and we go from the signal to all general classifiers, and then to the typed element of type and to the owner. And so the two of those together let us see what it can flow. So this is the direct ones, and this is all the ones that are further upstream. We could do a union to combine them all if we wanted to. So that's what we did there. Then I also set up an interface block here that's basically a connector. So this represents buying an off-the-shelf 4-pin connector of some sort, and we'll show you how we'll go about setting ourselves up for success here. So we've gone ahead and created subsystem A with 2 blocks that make it up, and I want to put a 4-pin connector on each ones with some pinouts. And so what we're going to do, normally I'm not a fan of having blocks own other blocks, but in this case we're going to make an exception. So we're going to have block 1 is going to own its own interface block that's going to type its port. And so we're going to call this front panel connector interface block, and we're going to have this specialize the 4-pin connector. And so we're going to have this specialize the 4-pin connector right here, and so that now is going to inherit all of the 4 pins that it has. And so we can come in here now, and we're going to go ahead and edit that by redefining them. And so if I come in here to the ports, you will see that the port 1 is, we're going to redefine it, and we're going to say that that is a 3 volt DC, a +3, and we'll make port 2 a -3, and we'll make port 3 an Ethernet, and we're going to make port 4 reserved. So I do a lot of metrics to check for typing of elements, and so if I left it blank, it would show up as an error. So we're going to go ahead and type this as a reserved pin. And so now, and later on, if we wanted to find all the reserved available pins in our model, we could just do a search on proxy ports of that type. And so there we go. And now that interface block is ready to go to type a port on this particular block. So I'm going to go ahead, I'm going to create the port. Actually, it's owned by the wrong... Oh, there we go. So we will go ahead. It's owned by block 1. And I'll just drag the front panel connector on to type it. And there we go. And so now I can show the port that it owns. And we now are able to display that. So I'm going to cheat because we want to be able to make the block 2 compatible. I'm just going to copy the interface block here in the containment tree. I'm holding the control key down and I'm dragging it onto block 2. So that makes a copy. So I just held the control key and dragged it, and I'm just going to rename this. Let's say this one's on the rear. So now that I've copied this onto block 2, I need to reverse the directions for some of these. So I'm going to go ahead and conjugate ports 1 and 2. And so I'll take a minute and do that. I'll conjugate that one as well. And so now those two are conjugated. So if we look over here in the containment tree, you can see that this front panel connector has outs and this has ins. And now we just need to create our port here. And I'm typing it with our own rear panel connector. So that's really convenient, and it's nice because if we end up copying these blocks somewhere else, they now own the interface blocks needed to type their connectors. So I can now go ahead and create an IBD here, and you will see that I'm going to go ahead and expand this, and we can see that we now have our front panel connectors. And so now I can connect these up. And notice they show up nicely at this level, which is great. But if I really care about the pinouts and want to get those correct, I can select the port. There's a choice here for display all ports, and now it shows the inside ones, the inner elements that we care about. And so now I can go ahead and the reserveds I'll leave. I can hook this Ethernet to this Ethernet. This -3 volt DC out, this -3 volt DC out, and these can go this way. And there you have it. So now we have, and I may have that backwards, I'm not a double E, but you get the point. So the fact is we now have specifically got the pinouts set up, and they're all set to go. Notice our auto arrange isn't the best, but you get the point. The nice thing about this too is that we now have the ability, because of this, to make sure that we put signals on the right type of connector. So if I put the -3 volt on the +3, you'll see this will throw an error here in just a moment, and so that works really well for us. So now I can show that I have 3 volts DC flowing here and -3 volts DC flowing here. Again, I'm not double E, that may need to be backwards, notice we have an issue here. That one's actually going the wrong direction, so I can come in here to refactor and reverse the flow direction, and that'll fix that error. So we're still throwing an error here, which means I must have the wrong type of flow property on the -3 volt DC interface block. So nice to see that I made that mistake. We can correct it, and in a matter of seconds that'll be fixed. So again, if you see behavior you don't know, track down the root cause. And finally we have Ethernet there, and I'll put the Ethernet signal on that, and now we have a nice and tight way to handle pinouts. And so again, notice that over here each block owns both the interface block that it needs to type the ports it has. So if you had a large number of ports, you could have as many interface blocks on there, specializing a whole variety of stock connectors. So you could just import a whole host of stock part numbers here with the number of empty pins they have, and you'd be all set. Thanks a lot for watching. Have a great day.